The reason why dividers between high and low voltage in a horizontal wireway application are often 4 inches, even when the wireway itself is 6 inches, comes down to a combination of code requirements, industry standards, and practical considerations. Firstly, the National Electrical Code, or NEC, plays a significant role. The NEC mandates a minimum separation distance between high and low voltage conductors within a wireway to prevent arcing and other electrical hazards. This minimum separation is specified as 4 inches in the horizontal wireway configuration. Secondly, most wireway manufacturers adhere to these NEC stipulations. By producing dividers that are 4 inches high, they ensure their products comply with the code and maintain compatibility with wireways from other manufacturers. This standardization simplifies installation and promotes overall safety. The use of a 4-inch divider offers a balance between safety and practicality. It provides adequate separation between high and low voltage conductors while still allowing sufficient space for electricians to access and work with the wires within the wireway. A taller divider, such as 5.5 inches, might not offer any significant additional safety benefits, but it would likely make the wireway more cumbersome to work with, potentially increasing installation time and difficulty. While a 4-inch divider is usually sufficient, there might be situations where a wireway with a larger divider height, like 6 inches, is necessary. This is typically the case when there is a high volume of both high and low voltage conductors that need to be segregated. In these scenarios, the increased divider height provides extra physical separation and minimizes the risk of interference or accidental contact. Ultimately, the choice of wireway divider height depends on the specific application and the number and voltage levels of the conductors being housed. However, for the majority of installations, a 4-inch divider meets both the NEC requirements and the practical needs of electrical work. The NEC acts as the foundational guide for electrical installations in the United States. It outlines the safety standards for electrical wiring, overcurrent protection, grounding, and numerous other aspects of electrical systems. Adherence to the NEC is essential to ensure the safety of people and property. Wireways, covered troughs used to hold and protect electrical wires and cables, are used extensively in industrial and commercial settings. They provide a versatile and organized way to route conductors, making it easier to install, maintain, and modify electrical systems. When running both high and low voltage conductors within the same wireway, physical separation becomes critical. This separation minimizes the risk of insulation breakdown, arcing, and other potential hazards that could result from the close proximity of conductors operating at different voltage levels. The 4-inch separation requirement specified in the NEC is based on extensive research and testing to determine a safe minimum distance that effectively mitigates these risks. Manufacturers design their wireway systems to comply with this requirement, offering dividers and other accessories that ensure proper separation. While the NEC provides the minimum requirements, some installations may benefit from exceeding these standards. For instance, in environments with high levels of electromagnetic interference, increased separation between high and low voltage conductors can help reduce noise and improve the performance of sensitive electronic equipment. Furthermore, in situations where future expansion is anticipated, a larger wireway with a greater divider height can provide additional capacity and flexibility. It is also important to consider the specific types of conductors being used in a wireway. Some conductors may have thicker insulation or require greater spacing due to their voltage rating or other characteristics. The manufacturer's specifications for the conductor should be consulted to ensure that the chosen wireway and divider system are appropriate. Installation practices also play a crucial role in ensuring the safety and effectiveness of wireway systems. Conductors should be neatly organized and properly supported within the wireway to prevent strain on connections and maintain adequate separation. Sharp bends and tight radii should be avoided, as these can damage insulation and reduce the ampacity of the conductors. All connections should be made securely and according to the manufacturer's instructions. Regular inspections and maintenance are essential to ensure that wireway systems continue to function safely and reliably over time. Inspection should include a visual examination of the wireway, dividers, and conductors for any signs of damage or deterioration. Connections should be checked for tightness, and any loose or corroded connections should be repaired or replaced. The Wireway should also be kept clean and free of debris that could accumulate and potentially create a fire hazard. In summary, the 4-inch divider height commonly found in 6-inch wireways is a result of NEC requirements, industry standards, and practical considerations. While other sizes exist, this dimension balances safety with ease of installation and maintenance. It is crucial to select and install wireway systems that comply with all applicable codes and standards and to perform regular inspections and maintenance to ensure their continued safe and reliable operation. The NEC is not just a set of rules, it is a comprehensive guide to electrical safety that reflects the collective knowledge and experience of electrical engineers, contractors, inspectors, and other experts in the field. Staying up to date on the latest NEC revisions and best practices is essential for anyone involved in the design, installation, or maintenance of electrical systems. This commitment to safety and professionalism helps to protect people and property from the hazards of electricity. In addition to physical separation, grounding is another critical aspect of electrical safety. Grounding provides a low-impedance path for fault current to flow back to the source, allowing overcurrent protective devices to quickly trip and energize the circuit. Wireways should be properly grounded to prevent them from becoming energized in the event of a fault. The NEC specifies the requirements for grounding wireways and other metal enclosures. These requirements vary depending on the size of the wireway, the voltage of the conductors it contains, and other factors. It is important to follow the NEC guidelines carefully to ensure that the wireway is properly grounded. Overcurrent protection is another essential element of electrical safety. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or short circuit. These devices protect conductors from overheating and prevent fires. The NEC specifies the requirements for overcurrent protection, including the size and type of overcurrent protective devices that must be used for different types of conductors and circuits. It is important to select overcurrent protective devices that are properly rated for the application and to install them according to the manufacturer's instructions. Proper labeling is also important for electrical safety. All circuits and equipment should be clearly labeled to identify their purpose and voltage. This helps to prevent accidental contact with energized parts and makes it easier to troubleshoot and maintain electrical systems. The NEC provides guidelines for labeling electrical equipment and circuits. These guidelines should be followed carefully to ensure that all equipment is properly identified. In addition to the NEC, other codes and standards may also apply to electrical installations. For example, local building codes may have additional requirements for electrical work. It is important to be aware of all applicable codes and standards and to comply with them. Electrical safety training is essential for anyone who works with electrical systems. Training provides workers with the knowledge and skills they need to identify and avoid electrical hazards. Training should cover topics such as electrical safety principles, safe work practices, lockout/tagout procedures, and the use of personal protective equipment. Regular refresher training is also important to ensure that workers stay up to date on the latest safety information. Electrical work can be dangerous, but it can be done safely with the proper knowledge, skills, and precautions. By following the NEC and other applicable codes and standards, and by providing adequate training for workers, it is possible to minimize the risk of electrical accidents and injuries. In the context of wireway installations, it's also relevant to consider the fill capacity of the wireway. The NEC specifies the maximum percentage of the wireway's cross-sectional area that can be occupied by conductors. This is to ensure that there is adequate space for heat dissipation and to prevent overcrowding, which can damage insulation and reduce the ampacity of the conductors. When selecting a wireway, it is important to calculate the total cross-sectional area of all the conductors that will be installed and to choose a wireway that has sufficient capacity. The NEC provides tables and formulas for calculating the fill capacity of wireways. In addition to the fill capacity, it is also important to consider the weight of the conductors. Wireways are designed to support a certain amount of weight, and exceeding this limit can damage the wireway or its supports. The manufacturer's specifications for the wireway should be consulted to determine its weight capacity. When installing wireways, it is important to use the correct supports and fasteners. The support should be strong enough to support the weight of the wireway and its contents, and the fasteners should be appropriate for the type of surface to which the wireway is being attached. The NEC provides guidelines for supporting wireways. It is also important to ensure that the wireway is properly aligned and leveled. Misaligned or unlevel wireways can put stress on the supports and fasteners, which can lead to failure. Before installing conductors in a wireway, it is important to inspect the wireway for any damage or defects. Any damage or defect should be repaired before the wireway is used. It is also important to clean the wireway to remove any dirt, dust, or debris that could damage the conductors. When pulling conductors into a wireway, it is important to use a pulling lubricant to reduce friction. The pulling lubricant should be compatible with the insulation of the conductors. It is also important to use a pulling rope or tape that is strong enough to pull the conductors without breaking. After the conductors have been pulled into the wireway, it is important to secure them in place. This can be done with cable ties, clamps, or other fasteners. The conductors should be secured in such a way that they are not subjected to excessive strain. Finally, it is important to test the completed wireway installation to ensure that it is working properly. This can be done with the multimeter or other test equipment. The test should verify that all conductors are properly connected and that there are no shorts or grounds. The tests performed depend on the voltage level. The information provided is for general guidance only and does not constitute professional engineering advice. Always consult with a qualified electrical engineer or contractor before undertaking any electrical work. Electrical work can be dangerous, and it should only be performed by qualified individuals who have the proper training and experience. By following safe work practices and adhering to all applicable codes and standards, it is possible to minimize the risk of electrical accidents and injuries. In addition, consider the materials of the wireway and divider. Metal wireways offer superior physical protection and are often required in environments where there is a risk of mechanical damage. Non-metallic wireways are lighter and easier to install, and they are resistant to corrosion. The choice of material depends on the specific application and the environmental conditions. Consider the ambient temperature in which the wireway will be installed. High temperatures can reduce the ampacity of conductors, so it may be necessary to use larger conductors or to derate the existing conductors. The NEC provides tables for derating conductors based on ambient temperature. Also, think about the presence of corrosive substances in the environment. If the wireway will be exposed to corrosive substances, it is important to use a wireway that is made of a corrosion-resistant material. Stainless steel and fiberglass are two common options. Furthermore, make sure to comply with all applicable federal, state, and local regulations. These regulations may have additional requirements for electrical installations. It is important to be aware of these regulations and to comply with them. Keep detailed records of all electrical work that is performed. These records should include the date of the work, the materials used, and the results of any tests that were performed. These records can be helpful for troubleshooting problems in the future. Finally, it is important to remember that electrical safety is an ongoing process. Electrical systems should be inspected and maintained regularly to ensure that they are working properly and safely. By following these tips, you can help to ensure the safety and reliability of your electrical systems. Selecting the correct wireway size is essential for safe and compliant electrical installation. The NEC provides guidelines and tables to help determine the appropriate wireway size based on the number, size, and type of conductors being installed. It is important to consider not only the current needs but also any potential future expansion when selecting a wireway. Overfilling a wireway can lead to overheating, insulation damage, and other safety hazards. Therefore, it is crucial to carefully calculate the conductor fill and choose a wireway with sufficient capacity. The NEC specifies the maximum allowable fill percentage for different types of wireways. For example, for wireways containing only conductors, the maximum fill percentage is typically 40%. This means that the total cross-sectional area of all the conductors in the wireway cannot exceed 40% of the wireway's cross-sectional area. The NEC also provides tables that list the cross-sectional area of various types of conductors. These tables can be used to calculate the total conductor fill for a wireway. In addition to the conductor fill, it is also important to consider the bending radius of the conductors. The NEC specifies the minimum bending radius for different types of conductors. If the conductors are bent too sharply, the insulation can be damaged, which can lead to shorts and other electrical hazards. Therefore, it is important to ensure that the wireway is large enough to accommodate the minimum bending radius of the conductors. In addition to the NEC requirements, it is also important to follow the manufacturer's instructions when installing wireways. The manufacturer's instructions will provide specific information about the wireway's installation, use, and maintenance. Ignoring the manufacturer's instructions can void the warranty and can also create safety hazards. In conclusion, proper wireway selection and installation are essential for a safe and compliant electrical installation. By following the NEC guidelines, the manufacturer's instructions, and best practices, you can ensure that your wireway system will provide reliable and safe performance for many years to come. Remember to consult with a qualified electrical professional if you have any questions or concerns about wireway selection or installation. Working with electricity can be dangerous, and it is always best to err on the side of caution. The selection of appropriate conductors for use in wireways is governed by NEC Articles 310.1 through 310.16. These articles cover conductor ampacity, insulation types, and allowable uses. The ampacity of a conductor is its current carrying capacity, which is the maximum amount of current that the conductor can safely carry without overheating. The ampacity of a conductor depends on its size, insulation type, and the ambient temperature. The NEC provides tables that list the ampacity of various types of conductors under different conditions. The insulation type of a conductor is the material that surrounds the conductor and provides electrical insulation. There are many different types of insulation available, each with its own set of properties and applications. The NEC specifies the allowable uses for different types of insulation. For example, some types of insulation are only suitable for use in dry locations, while others can be used in wet locations. When selecting conductors for use in wireways, it is important to consider the following factors. Firstly, the ampacity of the conductors must be sufficient to carry the load that they will be serving. Secondly, the insulation type of the conductors must be suitable for the environment in which they will be installed. Thirdly, the size of the conductors must be compatible with the wireway's fill capacity. Following these guidelines will help to ensure a safe and compliant electrical installation.